Use your calculator, right? Okay? All right, so this one, what's the GCF? 4x cubed, right? Oh, do I have that one? I gotta get that one going for you guys on the side. All right, so all right, I'll factor this, and then I'll do it on the calculator too. So what is it? 4x cubed, you told me, right? Then you get x squared minus 2x minus 8, right? Which is x minus 4 and x plus 2, right? Because negative 4 times 2 is negative 8, negative 4 plus 2 is negative 2, right? Okay, so if this times this times this equals 0, either this one equals 0 or this one equals 0 or this one equals 0, right? One of those three has to be equal to 0 if I multiply them to get 0. Make sense? That's called that zero product property. Okay? So what am I going to do to solve for x here? Subtract 2. So the answer is negative 2, right? What do I do on this one? Add 4. So the answer is 4, right, Grace? So far, so good? And then here I would divide by 4, but what is 0 divided by anything? 0. So if I take the cube root of 0, it's going to be 0, right? So since this is a 3 here, the 0 works 3 times. It has a multiplicity of 3. So when you watch your graph, if you put it in your calculator, what's the graph going to do when it hits the 0? No. It's going to curve, bend. If it's odd multiplicity, again, multiplicity only means that that 0 works more than one time. It works multiple times. Okay? So when you watch the graph, if it goes straight through it, and usually it goes pretty fast, it goes straight through, it only works one time. There's no multiplicity. If it bounces off, either going up and hits it and goes back down, or coming down, hits it, goes back up, it works at least how many times? Twice, even multiplicity. So it could work 2 times, or 4 times, or 6 times. Okay? And if it bends, like we just said, it has odd multiplicity, meaning it works at least 3 times. Okay? Now, how many zeros should I find? 5, right? This tells me how many zeros there are. Well, this works 3, so that's 3 zeros. That works once, 4. That works once. There's my 5 zeros. Even though there's only 3 that I see, the 1 works more than one time. It has multiplicity. Does that make sense? Okay? So some kids, when I'm asking for multiplicity, some of you say odd or even, which is right, but I want the actual number, 2 or 3, or 4 or 5, whatever it is. Okay? Usually we don't get, every now and then we might get x to the 6th, but usually x to the 5th is the highest we get. Okay? Now, this didn't tell us multiplicity. I added that in. But we got the 0, the negative 2, and the 4. Okay? Now, you don't have to factor it. You can use your calculator. All right? So just go with me here. If you haven't put it in yet, put it in. All right? Just for practice. Move that over so I can see it. All right, so this is x, 4x, so I'm just going to clear that all out. All right, so 4x caret 5 minus 8x caret 4 minus 32x caret 3. All right? Now, when I hit graph, I have to watch what happens. Because I'm looking for straight through, I'm looking for bouncing, and I'm looking for bending. Okay, usually if it bends, it goes a little slower. Okay? So, I'm thinking, again, I'm not quite sure how it looks. I'm thinking it goes down through -2 and starts coming back up to the 0, and then it'll bend through the 0 and then come back down through the 4. Okay? It might go up through -2 and then come down to the 0 and bend, and then up through the 4.
How do I get to that again?
This?
Yeah.
Y equals.
Oh.
To graph any line, you have to hit the Y equals button. But not for now. Okay? Do you know how to do it? No. All right, here I'm going to do. I'm going to hit graph. Oh, you know what? Did you see how mine was just now? It was kind of zoomed in. So how do I get it back to normal? Zoom. What number? Zoom 6. Right? When I hit zoom up here in the middle, 6 is the standard one. That's the basic one that you always see. Down quick. Actually, it went really fast. But you can kind of tell it moved, you know, kind of bent as it went through the 0. Okay? But you got to pay attention when you watch it. All right, so where can I look to make sure I got the right numbers here? Let's just do this. This looks like a -2, a 0, and a 4, right? But to make sure, where do I look? Table. How do I get to table? Second graph. All right? There's the -2, there's the 0. If I go down, see if we can get them all in there. I think I can. Yeah, I can get them all in there. All right, so there's the table. -2, the 0, and the 4. Okay? Anybody having issues with their calculator? What? Yeah, it keeps going.
I found the 0, so it's
Yeah, it'll just keep going forever, yeah.
I don't know why. It showed me like
Okay, so now you're gonna have to, let me get you back quick.
Go to heat line. Or that one.
Okay? Question. If I were doing synthetic division, what do I have to do on the end here? Add a 0 for x squared, for the x, and the constant. I have to add 3 zeros. There's my 3 zeros then when I would do synthetic. Okay? Is that helping?
How do you know when to do synthetic?
If you want to check to see how many times it works. Okay? But I'm trying to teach you to look so that if you see it bending, you should know it works how many times? 3. So you count 3 for that one, 4, 5. So there's your 5, right? You don't really have to check. Any other questions? Is that helping? Just going over that one again. Zach?
What would I ever actually use this for, other than this class? I'm just like, what would I ever need this for?
I don't know. Solve some kind of problem. It has lots of things in it. Again, algebra, I know you're not specifically gonna find zeros to some polynomial, but are you gonna have problems you gotta solve in mind? Yes. So algebra basically helps you learn how to think and think through solving problems.
Yeah.
Right? Factoring, like, what's the common theme here in this problem? That's like the GCF you're pulling out, right? And if I can fix that GCF problem, then maybe I fixed the problem that I'm working on. So again, it's just helping you learn how to think, hopefully. All right? So, homework answers from $443. What was the first one we had to do? 24? Okay, 24 was -2 and +2. Did we use 26?
Yeah.
All right, we got 0, 1 plus the square root of 3, and 1 minus the square root of 3. If you did in your calculator got a decimal, 1 plus the square root of 3 was 2.7. So if you got 2.7, you did it right. And then 1 minus the square root of 3 is -0.7. You did it right. It's okay. Okay? What did we do after 26? 30? Was that it?
Yeah.
30 was -2, 0, and 2/5, which is 0.4. Then what was the last one? 33?
Yeah.
All right. And there were 5 of them there. -1, 0, 1. 2 plus the square root of 5 and 2 minus the square root of 5. 2 plus the square root of 5 is 4.2. And 2 minus the square root of 5 is -0.2. All right, if you did it using the calculator. All right. Let me show you something on that one. Okay. All right, that's today's stuff, right? Okay. Let's go back. Go down here. What was that one, 33? Right? So, x to the 5th minus 4x to the 4th minus 2x cubed. Olivia Carr, what's the rest of it?
1/4 third times x
Nothing else?
equals 0.
Okay, thank you. All right, so I gave you the answers. Any problems getting those answers? -1, 0, 1. Any issues getting those? Where are we gonna get them? How'd you get them? How'd you find them? Yeah, I solved it, but what did you do? You put it in the calculator, right?
Calculator.
Yeah, you gotta use the calculator, right?
Yeah.
All right, so, you can use the calculator and go second trace 0 to find those decimals, right? I went through that, didn't I? Yes, no? Yeah, I did, right? Okay, let me show you something. If I put, the -1 in here, I got a 1, -4, -2, 4, 1, and I have to add a 0 on the end. Drop the 1 down. Some of you still don't have this. Okay? What do I do now, Nicole? Yes. -1 times 1. Some of you are doing that negative 1 times 1, and you're putting that 1 under the first one. Remember, the first one goes below. Okay? Now, what do I do with these? Add.
Why is that a negative 1? I'm confused.
Oh, it should be negative 1.
Oh.
You should have been confused.
I'm confused on where you got that root on this one.
This?
On the left, the 2 radical 5.
That's what I told you what the answers were.
Oh, so you're telling us that?
Yeah.
We didn't have to solve that?
No, you should have gotten those, but I'm gonna show you how that gets there.
Okay.
All right?
Okay.
So, those 3 you can find on your table, right? These 2, you can find it in your calculator using second trace 0, right? But I'll show you how to do it without using the calculator. All right, so negative 5. Sorry, I made a mistake already. Negative 1 times negative 5, positive 5. Negative 1 times 3, negative 3. Negative 1 times 1, negative 1. Negative 1 times 0 is 0. So I got the 0 I was supposed to get, right? That's what's supposed to happen. If I don't get a 0, what's that tell me? I made a mistake, right? Because the calculator told me it's supposed to be a 0, right? Okay, so just check your signs. Like I would have made a mistake if Olivia didn't say, why wasn't it negative 1? Because I put positive 1 there. Okay? Now, don't start over. Put the 0 in there. And you can stop at the next, that last one you don't have to put in this now. Again, drop the 1 below. All these are zeros, right? So that works, right? Now I put the 1 in. One times 1 is 1. 1 times negative 4 is negative 4. 1 times negative 1 is negative 1. All of you, even if you were quarantined, should be able to do synthetic division by now. Any questions on synthetic division? That's simple, right? Now, remember, this first one was x to the what? 5th. So this one is x to the 4th. This one is x to the, this one is x to the 2nd. All right? So this problem right here is x squared minus 4x minus 1 equals 0. Okay? Can you factor this? Are there factors of negative 1 that add up to negative 4? No. So how do I solve that quadratic equation?
Calculator.
No. I said, we already did it with the calculator. I'm showing you how to get these 2. That's what Olivia asked me, remember? Use the quadratic formula.
What was that again?
I really thought that was okay.
Why do I have to teach this to you?
You're sitting in the class.
Nicole, pay attention. You tell her, Jordan. I'm going slow. It's not that bad. What's B? Negative 4. What's A?
1.
What's C?
Negative.
We've done this before, right?
Yeah.
Yeah, you did it in Algebra 1. Okay? So, positive 4. What's negative 4 squared? 16. Negative 4 times 1. Negative 4 times negative 1.
4.
Right? What am I going to do with those 3? How do I simplify? Divide by 2. Right? 2 plus or minus 1 radical 5. Are those the 2 that we were looking for? Yeah. Do you have to do that way?
No.
No. You can give me the decimal answers using your calculator. I just want to show you how this synthetic division helps you simplify that big long x to the 5th down to an x to the 2nd. That you know how to do already, because we've done a lot of quadratic equations already. Yes, sir. I'll show you later. All right, we got to move on, but I'll show you exactly. All right, so all these are equivalent statements. All right. A real number r is a root, or we could call, instead of root, we could say what? 0 of the polynomial equation. So whatever r is, when I put r in place of x, what's the answer? 0. Remember, when it's a 0, that's where it crosses the x-axis. We call those x-intercepts, right? If r is a 0, then x minus r is the factor of the polynomial. When you divide by x minus r, the remainder would be 0. When we did synthetic division, we get a 0, right? And then again, they say root. Here we always say 0, so I guess I didn't have to put that. Okay, so you're given the zeros, the roots. They want you to go backwards to find the polynomial that goes with it. We've done this before already. How do I always start the factor? X. What'd you say? No.
X squared cubed.
Thank you, Sandy.
All
That's how you start the factors every time. How many times? Every time. Say it with me. Every time. That's how you start the factors. Okay? So, why'd that become plus? It's minus a negative 1. There's the minus 4. If you have a fraction like this, the denominator goes in front of the x minus the numerator. Okay? So D for denominator, N for numerator.
Why is that a negative?
It's always x minus. Okay? And again, this one was a plus because it's x minus negative 1, which minus a negative is addition, right? Then what do I do with those 3 binomials? Multiply them, right? FOIL them. Can I FOIL 3 at a time? No, just 2 at a time. Okay? It doesn't matter which order. Okay? All right, so I'll just do these 2. What's x times 3x? What's x times negative 2? 1 times 3x.
3x.
1 times negative 2. Combine like terms. times what? X minus 4, right? All right, then I go 3x squared times x. And 3x squared times negative 4.
Well, negative 12.
Then x times x.
X squared.
And x times negative 4.
Negative 4x.
Negative 2 times x.
Negative 2x.
Negative 2 times negative 4.
Positive 8.
Are there like terms? Yes. So my answer is is this multiplication stuff anything new for us? No. Simple, right? So, how do we start the factors every time?
Minus.
X minus, right? Every stinking time. Okay, so how would I start?
X minus. X subtract.
Plus 2.
And then multiply, right? You good?
Yeah.
Okay. Notice that the degree of the function, example 1, is the same as the number of zeros, right? We knew that, right? Isn't that what we've been doing? If I have to find the zeros, I know how many I should look for, right? Okay, that's all that's saying. Okay? We're going to have complex roots. That's when we have what? We have square root of 3 or something like that, or 2 minus I. Those are complex roots. Okay? They always come in pairs. Did I spell it right? They always come in pairs. So if there's a square root of 3, its pair is negative the square root of 3. If there's a 2 minus I, what's its pair? 2 plus I. We call them conjugates, right? Remember that? That's nothing new, right? We had that before. We've been, all right? All right, so that's finding all the roots. That's what we've been doing, right? Use the what? Use the calculator, right? What are my zeros? Right. Just see where, is there any bending or bouncing? No, so they work how many times? Once. How many are there supposed to be? 4. So I got to find the other 2. So how do I simplify it down to find the other 2? Synthetic division, right? Just like we just got done practicing, right? Do the negative 1. Does it matter which one I do first? No. So the other one was 4. You could have started with the 4. Do the 4. You're supposed to get what in each one? 0. So this started out as x to the 4th. This is x to the, what's this? Squared, right? So x squared plus 0x, I don't need the 0x, right? What do I do with that 9? Subtract it. What do I do to get rid of the x squared? Square root. What's the square root of negative 9? Plus or minus 3i. Imaginary. That's why we couldn't see it on the calculator. Okay? That's a complex number. It has 2 of them, right? Because they come in pairs. Okay? So, if it tells you there's a 0, 2 plus I, you know there's also a what? 2 minus I. If there's a square root of 3, you know there's also a negative square root of 3. So how many zeros does this actually have? 5. All right, how do I start? X minus, right? There they are. X minus, you don't have to put these parentheses. Just write x minus 2 plus I. X minus 2 minus I. Right? Don't worry about the parentheses. X minus the square root of 3. What's minus a negative? Plus. And then your x minus 1. All right, when you multiply it out, we're going to run out of time. That's okay. We'll do this tomorrow. You have to, though. Pay attention to this. You have to multiply these two together first. What's going to happen to my i's when I do those two together? They'll go away. You have to do these two together. What's going to happen to the radicals? They'll go away. If you don't do that, you make a mess for yourself. Do you want to make a mess for yourself? No, you do not. Okay? So, I'll go through how it works tomorrow. How many terms are in these two? Well, in that one, how many are there? 3 and then 3. So how many terms will there be when I multiply them? 9. Okay? But remember, the i's will go away. What's I squared equal?
1.
Wrong.
Minus 1.
-1, right? Don't forget about that if you run into one of those. Hey, you guys did a good job today. I know I threw a lot at you. We will practice this some more tomorrow, so just try them all. Don't get overwhelmed. If you get frustrated, you'll have it better tomorrow. It always is better the second day.